So the first note I want you to get, elimination is a third method of solving systems of equations. So we've been talking about systems, and we've been talking about systems have two or more equations. We're going to deal mostly with two, but another method to solve for those systems of equations is called elimination. And elimination is technically going to cover two of our lessons, 8-3 and 8-4. But I'm going to split up into 3 lessons to make sure you guys really get it, because it's very helpful, but you have to make sure you're doing it the correct way, obviously, so that it works best. All right, so I'm going to explain some things to help you to understand, hopefully, why we're allowed to use elimination. And I kind of gave it to you guys, because I think it was a class, where I gave you a reason why you can do an addition of equations. Do you guys remember adding 2 equations together at the very end of class?
Yes.
Okay, we added 2 equations together. You're like, why did we even do that? And how is that even possible? So let's look at example 1. And let's look at a couple of equations. Okay, so I'll ask the question here. Can I solve this system by graphing?
Yes.
Yes. Can I solve it by substitution?
Yes.
Yes. And now we're going to look at elimination. So I could use the other 2 methods, but I'm going to use a third. And before I get into that, I'm allowed to add equations such as these 2 because I'm just using the properties we've looked at before. Okay, so please listen carefully. Look at the top equation. Would you say that 3x minus 2y is equal to 4 according to that equation? Yeah, that's what it says. That's what we're going to go with. And would you also say that 4x plus 2y is equal to 10? Okay, so can I say that 4x plus 2y is the same thing as 10? I mean, is that allowed? Like, am I being proper in using that? Okay, and I'm using the same thing purposefully. Can I add the same thing to both sides of an equation? Okay, ready? Let's see if you guys can see it, and I'll point it out several times in this lesson. Okay, the reason I'm allowed to add these 2 equations together like we did in that last lesson was, look at the top equation again. Am I allowed to add the same thing here as I am there? So am I allowed to add the same thing to both sides? What if I add to this side 4x plus 2y, and to that side I add 10? Is that proper? So I see some people saying yes, some people are like, What do you think? If I added 4x plus 2y here and 10 over here, did I add the same thing to both sides?
Yes.
Well, yeah, because don't they equal one another? So when you combine these 2 together by adding vertically, you're adding the same thing to both sides of the equation. It looks really strange, doesn't it? Okay, let's go ahead and do that. Let's add the 2 equations together. Let's see what happens. Okay, so I draw a little addition bar. What's 3x plus 4x?
7x.
Okay, 7x. What's negative 2y plus 2y? These got eliminated. Okay. And what's 4 plus 10? So I have a third equation, which is 7x equals 14. You notice anything about it? How many variables does it have?
1.
Can you solve for that one? All right, let's go ahead and solve for it. Divide both sides by 7. And I'm left with x equals 2. Oh, interesting. So you see how I got 2? Okay. I already have half my answer. The first number is 2, and I need to find the second one. How do you think we need to find the second number? You tell me.
The same thing.
As what? I mean, you could do the same thing again, but there's another way that we've already looked at with substitution. Jenna?
Maybe subtract.
Okay, maybe like subtract the 2. Okay, if we add it, maybe we subtract. I'm talking easier than that. Yep.
Wouldn't y just be 0 since
Oh, I see. Since they got canceled out, it seems like that, but it's not going to work out. If I put x is 2 and y is 0, it doesn't work out. Okay, ready? This is how you do it. Do you remember the third step of substitution? What was that third step? Substitute the known variable to solve for the unknown. So what I can do here is I can put x in for 2 in for x here or here, and solve for y. So which one do you want to pick? First, second equation. All right, here's second, so I'm going to go with that. 4 times 2 plus 2y equals 10. I'm going to separate that right there. So you see I'm using that second equation, and I put in 2 for x, hopefully, 2 for x, and then I can solve for y. So 4 times 2 is 8 plus 2y equals 10. Subtract 8 from both sides. I get 2y equals 2. So y equals, 1. Okay. That's my solution. But it isn't my solution.
Yes.
So much. What? Oops. Okay. All right. Can we check in the first one here? What's 3 times 2? 6. What's negative 2 times 1?
-2.
So 6 plus negative 2 is 4. Check. 4 times 2? 8. 2 times 1? 2. 8 plus 2 is that the solution? Huh. Interesting. How many of you like elimination? Like, you seem like you might like it. I actually had, I was telling another student that I actually had like a long drawn out process of telling you how to work it out. But I might write it still, but it's actually not that hard as in intuitively. Yep. Yes? Okay. All right, you guys okay with that? Okay, let's do it again. Because sometimes the first time is not the charm, so we need to make sure we get it. On page 472, we're going to work out number 5. Okay, so here's my system. I could graph it. I don't want to graph this. I can substitute. Might be tough to substitute. I can use elimination because if I add the two equations, guess what's going to happen? What's going to be eliminated if I add the two equations? The y. So look, I'm going to draw my little addition. And some people put like the addition sign, so you're saying you're adding these two. Fine. And this one works out similar to the last one. But what's 3x plus 4x? 7x. What's negative 5y plus 5y? Eliminated. That's the elimination method. And then what's 3 plus 4? 3 plus 4, 7. Mm-hmm. What do you do to both sides to solve for x? X equals 7. Oh, wow. X equals 1. Okay. Do you know how to find y?
Yes.
What do you do?
You put it into 4x plus 5y is equal.
Yeah, you can put it into this equation or that equation and solve for y. So go ahead and do that. That's review. So find y. You find it. If you have it, hold it. You have it?
I have a question.
Oh, sorry. Okay. Mm-hmm. It's 0 divided by negative 5 is 0. That's what that would be. I think I have like some kind of sugar high. My head is kind of hurting right now. Yeah, I don't know why. I had a lot of energy and just went away. But anyway, you guys are doing very well. How many of you got 0? What was it? Divided by negative 5? Yeah. 0 divided by negative 5 is equal to 0. So you should get 0 here for y. So are you allowed to get 0 for one of these ordered pairs? Of course you are. That's a point on the graph. If I were to graph it, this graph, these two lines meet at 1, 0. So that's where they would meet. Okay? Sound easy enough? Okay. Let's have you try it. Let me give you one here. Sorry?
I'm going to do multiplication.
Yes, that's the next lesson. This is actually not that. I almost can just teach it all today. But we'll see. Okay, let me give you this problem here. I'll make it a little bit tougher. All right, keep working, guys, and stay quiet.
That's the most interesting thing we've seen all day.
So use elimination to solve this equation. All right, somebody raise your hand and tell me what you did first. Just give me your first thing. Jackson?
So you do like the adding thing, the equation.
Okay. What do you get?
3r equals 6.
Okay, those got eliminated. And then r equals
2.
2. All right. And then your alphabet is rs, so r goes first. Okay, and then how do you get your, somebody else, how do you get your s? Or how did you get your s? Lily?
I did use the second equation and
Okay.
put 2 minus s equals 1.
And what fits for s?
Positive 1.
Positive 1. So you got. Did anyone use the top equation to solve for s? Did you also get 1? So regardless of the one you use, you should get 2, 1. The other way? This way? Oh, I see. So yeah, it seems like that, right? You're going to get negative s equals negative 1, but then s equals 1. Mm-hmm. So how many of you would say elimination is pretty easy? So far, it's easy. All right, let's go to another example we'll do together. And it's on page 472. We're going to do number 7. So this is where we add a little twist to it. If all elimination problems are like that, man, this is easy. And I would like it, but they're not all like that. They get a slight variation to them. So negative 4m plus 2n equals 6. And negative 4m plus n is equal to 8. All right, so this is a system here. And if I want to use elimination, this is what's going to happen. So I'm going to add these up together. Don't write this next step down. This is what I'm going to do. All right, if I add these two, what's negative 4m plus negative 4m? Negative 8m. What's 2n plus n? Plus 3n equals 14. Did anything get eliminated? Wasn't very helpful. I don't want to do that on this problem. Can't do it, actually. It doesn't help. Oh, man, who thought of this? Okay, but there is something I can do. Man, wouldn't it be so nice if these two 4m's had opposite signs? Because then when you add them up, what happens? You eliminate them. Just a moment. Okay, thank you very much. Yeah, be kind to the visitors. Thank you so much. Thank you, guys. All right. I wish I could make maybe this one negative and that one just change that to positive. Wouldn't that be really nice? Is there any way I can make them? Okay, there is subtraction, but there's a better way, and we're going to use this better way. The person in the blue.
I wear more blue.
The girl in the blue or the guy in the blue?
That sounds good.
Have blue.
Whichever one you
All right, Jenna, go ahead. Now you decide who has more blue. All right, listen up.
Feminist.
I want to hear what she's saying.
Multiply one of or bottom or top the entire equation by -1.
Okay, either one will work, but if I multiply everything down here on the bottom one by -1, what happens to all the signs? They all change. I get positive. This becomes negative. Oh, this becomes negative, and that becomes negative, right? And are you allowed to multiply everything by -1? Yep. So now if I add these two together, what's -4m plus 4m?
0.
They got eliminated. So elimination worked. What's 2n minus n?
1n.
Yeah, 1n or n. And then what's 6 plus -8?
-2.
So what does n equal?
-2.
Okay, so I got it. So m and n comes second. So I got my -2. How do I find my m? Mr. Harder. Okay, go ahead, Jack.
You put -2 into the top equation.
The top one here? All right, so we'll have -4m plus 2 times -2 is equal to 6. Okay, you actually had three choices. The first equation, the second equation, and do you remember, didn't we change this equation down here? You could have used the original second equation. You had options. Any one of them would have worked, but let's use this one. Yeah, because n is negative.
No, it's not. You replace the negative. That's either the top or the bottom side.
Oh, okay, yeah. Thank you for clarifying that. Yeah, I used the top one. You could do the bottom one. Just make sure it's minus -2, which is really plus 2 if you use the bottom. All right, but anyway, -4 equals 6. And then add 4 to both sides. So I hear a lot of talking, which means we need more to do. If you divide both sides by -4, you're going to get -10/4 or -5/2. And that's your answer. Are you allowed to get fractional answers?
You are in algebra.
Start expecting them.
You can do whatever you want.
Does anyone know what -5/2 would be?
Oh.
Yeah.
It would be like -2.5.
-2.5. So -2.5 on the y-axis. So that's where they meet. Okay, do you guys get that? Get how this works? So sometimes it's very clear, like the first few examples, and then sometimes you can change the equation to make it easy to eliminate. Okay, try out number 8.
Sorry, why can't you just get this from the beginning?
You think this is the best method?
Because there's other.
Ah, interesting. Okay.
Oh, really?
Because a lot of times with problems, we have to fix them. See, I think I did. At first I was confused.
And make sure I write it correctly. Minus 2. All right, make sure you're quiet. And I'll just give this as the last warning, just because it's getting distracting. So use elimination to solve here. When I look at this problem, I'm thinking, okay, elimination, not too bad. I got it. Substitution would have been nice as well.
No.
Because could anyone tell me what I would use for substitution? Jack?
Substitution, you would find the A value
Find the.
or the B value.
I would find this B value, and then I could substitute it into that second one, solve like I did with substitution. Yes, ma'am?
When you get that B, like basically minus the BB, would it be -2?
Did you change anything? Because if I add these up, when I get 16a minus 2b equals 4, so I got to change something first. All right. Emery, what did you change? Which one? Top or bottom? Okay. So some of you did something different, but we can do this. if I multiply everything up here by -1, I'll get negative 8a minus b, and then negative 1. So here, and then I get negative 4b equals 2, and then divide both sides by -4. b equals negative 1/2. That's my b, that's my second value. Okay. All right. Did anyone, don't give me the answer, but did you get A already? You got A? Oh, sorry. Did anyone get B? It's only some. Okay. If you didn't get B, now there's B for you. Find A. So, like, if you need help, that's okay. Yeah?
Why was we go ahead and change it?
Because if I added the original equations, remember this was positive? So that would give me 16A.
Oh, right.
That doesn't eliminate. I want one of them to eliminate. Next week, we're going to look at this problem. We're going to look at this same type of problem and say, yeah, I could eliminate the A's, but I can also eliminate the B's. Does anyone have an idea of how to eliminate the B's in this problem? You could do division. What if I had this being positive 3b and that being negative 3b? I mean, would they eliminate? Okay, so what if I multiply this by negative 3? Would that give me positive 3b? And I'd have to multiply this by 3b and that by 3b, and that would give me it. So, or negative 3b, I should say. We're going to make it easier. Some of these problems get tougher. Like this, I wish this is how tough it was, but it's not. It gets tougher. All right, does anyone have A? Carson. Okay, go ahead.
116.
Ooh, very, very close. Matt? 3/16 is the answer. Oh my. Okay, how many of you got negative 1/2 but did not get 3/16? So 3 of you? Okay, so Matt, which one did you use, the first or second? Okay.
I used the first one where I put in 1/2.
Okay, I'm going to use the first one, and I'll put negative 8a minus negative b equals negative 1. Do you guys see that? Negative 1/2. It's the opposite of negative 1/2. Okay, so here I'm going to rewrite it to clarify it. Negative 8a plus 1/2 equals negative 1. All right, I think some of you don't like fractions. So what do you do to all of these numbers to get rid of the fractions? Multiply by 2. So I'm going to get this. What's negative 8a times 2? Negative 16a. What's 1/2 times 2? 1. And then what's negative 1 times 2? So I could have used that as well. Everything got multiplied by 2. Yes? Didn't have to, but...
If you were to do that, would you be allowed to do that on homework and still be correct?
Yeah, or like this?
Yeah, like trying to get rid of the fact.
Yeah. If you want to do that, that's okay. Yep. Just show me that you're doing that. I get negative 16a is equal to negative 3. Then I divide both sides by negative 16. And I get positive 3/16. Yeah.
So on our homework last night, we did this, but we still come out with the same answer.
Yep. Okay. Remember what I told you guys yesterday, that on the test at the end, I'm going to give problems, systems of equations, and say use a method to solve. Which method can you use? Graphing, substitution, or elimination. You pick. Sometimes graphing's easy. Sometimes substitution, elimination. It just depends. Yeah.
So it doesn't matter which, either the top or the bottom you.
Yes, it doesn't matter. If I wanted to make all of these signs change, it would have been negative, positive, negative. It would have worked. Yeah. Yes, ma'am?
On the test, you have like circles or whatever. You make us like do like
Yeah, I'll say solve by graphing, solve by elimination, solve by substitution. Yeah. Because I want to give you those tools, develop those tools. All right, your homework tonight. It changed, guys, so be thankful. It changed. It's 15 to 23. All. 9 problems. No, 23 minus 15 is 8, but you have to add 1 for the one. So count them up. You'll see you'll count 9. Yep.
What if you don't understand like the other way to do it and you just use the elimination?
No, ask me a question and do it that way. Because if you don't understand how to do it on some of these little ones, then you might not know how to use it on one where you have to use that method. So like,
Can I do last next one?